Hello everyone. Today let us learn ray diagrams for spherical lenses. Before that, we need to understand few terms. So here I have drawn two circles. These two circles intersect when the center, if I take compass, keep here and draw the circle from this side and for the center. So we have seen these two spheres. So the intersecting part, this part is taken as a lens, the sphere. Okay. Same way, in this case, here two circles, but these are not intersecting. In this case, this sphere, the arc of the circle and this part, the spherical one is taken and a lens is formed. This we call it as concave lens and this one is convex lens. Convex lens is a converging lens and concave lens is a diverging lens. Now, moving on with here the ray diagram required. Before that, let us understand here the line joining the centers. Just now I showed you the two centers. That line joining is called as principal axis. The center of the spherical lens is called as optic center, and the part which is available for refraction is aperture. This part is aperture. Now here you can see I have written here focal length this side as well as focal length. The distance from the optic center and to the principal focus is called as focal length and it is denoted by small letter f only. Now problem here is which side we have to take it as primary focus and the secondary focus. Now your LHS left hand side, when an incident ray travel parallel to principal axis, they meet at f2, that is the other side. So that is taken as secondary focal length, that is f2, and double of it will be 2f2. The distance of here O f1, f1, 2f1 and O f2, f2 to 2f2 all are equal. They are equidistant. The same way here, the point again in your LHS side, from where there is a certain point from where the rays, when after refraction, they pass parallel. So that point is taken as primary focal length. Okay. Okay, now the rules required for a ray diagram. Here as in mirror, we have certain the convenient rays which we take to draw the ray diagrams are. This is convex lens. Rules I have written. Only 3 are there. So we saw this one, the incident ray which is traveling parallel. After refraction, I have drawn a line over here. So this is air and 2 glass. So light ray is traveling from rarer medium to denser medium. So there is a refraction, change in medium occur and it bends, light ray bend. And this will pass through F2. So this is rule 1. Second one, an incident ray which travels to F2, F1. And after refraction, after passing through the lens, again change in medium, it will travel parallel. Third rule here, the incident ray which travels to optic center, it travels undeviated. It will not bend refraction here in this case, so it is undeviated. So usually we will be using here this rule 1 and rule 3 for our ray diagrams. Same rules apply for concave lens as well. Lens here is concave lens, parallel to principal axis. We know it is diverging. It will diverge, the ray diverge, but it appear to pass through F1. Then here, if the incident ray is passing through focus, then it will travel parallel to the principal axis after refraction. And then the last one, incident ray passing through the optic center, it will pass undeviated without getting refracted. Okay. Now let us start with the ray diagrams. The first position I have written here, object at infinity. We'll place the object at infinity, that means beyond here. So initially no need to show the object here, we'll just draw the ray here. I have not drawn the lens here yet. Check out, this is our thing. To get a perfect ray diagram, first to draw line, I will take the first rule here, parallel, and then here one more ray, incident ray, parallel. From infinity, this is traveling. So after refraction, so show the bending here at this particular line. So it will help us to draw the ray diagram perfectly. Look. So now after refraction, it will pass through. Don't forget to draw the ray arrow marks. Now after this, the point image is formed at f2. Now at this point, I have taken here 1.5 and 1.5 above. Now after drawing the ray diagram, draw the lens. Do not forget to draw the lens here. Then write about the image information, where the position here is at image position is at f2. How is the size? We can see here it is point size or it is highly diminished. Highly diminished. Right? It is at f2. It is point size. Size is highly diminished. Nature. It is on the other side of the lens. So it will be real and inverted. It will be real and inverted. Fine. Uses this particular at infinity. The object here, it is used in astronomical telescopes. Okay. Now the second position, object AB beyond f2. One more here, the point you need to take when you are placing an object AB here I have shown. Let it be either 1 centimeter or 1.5, not more than that, because it will not fit in properly in the book. Fine. Now what you do, same two rules we'll be using. First one, traveling parallel after refraction. This line from here show the bending refraction, pass through F, extend it, draw the arrow mark here in this case, and one more we will draw, that is from here, third one. It is passing from center here. Look, it will travel undeviated this way. Where these two rays meet, there is the image formed. Draw here this case. We can name this as A dash, B dash. Here I have shown arrowhead on the top. So this inverted because it on the other side. So we are here working out convex lens. Take the draw convex lens. The two rays which you are using, it should be inside the aperture. Do take care about those when you draw it. Then position here, it is where whenever the word beyond, then it will be between f2 and 2f2. Size here is diminished. You can see here this one 1.5, it is hardly 1 centimeter here. So this is diminished, not highly diminished, just diminished. Nature, real and inverted. This here the position is used in cameras. Okay, just check out once again. Only these two rules we are using. Moving on with the next position. Here object AB, just named it as AB, at 2f1. So again same thing. You might have noticed I am drawing the lens afterwards. So first draw parallel, same thing. Then it passes through. Here focus, one more. It will pass through optic center undeviated. So we get here at 2f2. So A dash, B dash, image is formed at 2f2. Draw the radar incident ray, refracted after refraction. Then draw the lens here. Then the position of the image here, it is at 2f2. At 2f2 size, it will be same size. Here it is 2f1. This is 2f2. So it will be same size as object. Nature is real and inverted. Where these two rays meet, there is the image formed. Fine. Then this is used in this position, terrestrial telescopes. I hope it is clear. See, part is very easy. Only two rays we are using. Now moving on with the fourth position here. The object AB is placed between F1 and F1 and 2 F2. So again, as I told you, do take only 1 or 1.5 centimeter. Draw only this line here. We will draw it ray diagram parallel. Then it passes through F2. Second ray here. It should go through O. If it is not meeting, do extend the lines so they meet here beyond to F2, between, beyond. So image information, position of the image here is beyond to F2. Size, you can see it is enlarged, not highly enlarged, comparatively it is bigger, enlarged. Nature, it is still real and inverted. Uses, in this case it is used in cinema projectors. Cinema projectors. Draw the lens. That's it. So, moving on with the fifth position, that is object AB at F1. Draw here object AB, same rules, parallel, then let it pass through F2. Extend, try to extend and see whether they meet. No, they will meet at infinity. These rays will meet at somewhere at infinity. Image will be formed, but at infinity. So position of the image is at infinity. Size here is enlarged, highly enlarged. Highly enlarged. Nature will be, see, before this side of the lens only, it will be real and inverted only. Real and inverted. Uses, it is used in searchlights. I hope you all are familiar with this. It is used in searchlights. Do not forget to draw the lens. Let it be symmetry. Here how much it is above the same part. So do draw the freehand drawing. It will help you. So the refraction, you can show it in this way. Now moving on with the last case for the convex lens. Object AB is placed between F1 and O, optic center. Here also we will use the same rules. Let us see what happens. Travel parallel, and then from here it should pass through F2, then through focus. Still they do not meet, not even this side they do not meet, not even at infinity. So what we will do, we will produce this back, the ray from F traveling parallel. So we'll produce this here. This ray also we will produce it back, and they will meet in front of the lens. See, look at this point. So when they are produced back, these two rays meet and the image is formed in front of the lens, and it is, this is A dash B dash. We'll draw the lens here this way. So we can see enlarged and virtual erect image is formed. So we'll write the position over here. Position is behind, the same side of the object. Same position, same side of object. Nature, virtual and erect nature, virtual and erect. Size here is enlarged. Size enlarged. It is used in simple microscope. Simple microscope. So this is a special case. In all the other cases we have seen real and inverted images formed only for the position where the object is placed between F1 and optic center. The image is virtual and erect. Do remember this case, it will help us in numericals. Now moving on with the next, that is concave lens. Here we don't have any more cases in this one. First we'll place our object at infinity, that is here, so ray of light. In this case we know this lens, concave lens, is a diverging mirror. So when we draw a ray coming from infinity parallel to principal axis, it will diverge. This will diverge and it will appear to meet at, we will produce it back such that it will appear to pass through F1. We will draw one more ray here, in this case parallel from infinity, diverging. Then here this side also it will diverge and it will, when produced back, it will appear to meet at F1. So image here is formed. Image is formed at F1 or on the same side of the object. We will not write it here as this, at F1 or on the same side of the object. When it is on the same side, then it should be virtual and erect. Okay, this is nature. Size is here point size or diminished, highly diminished. Nature is virtual erect, size is point size, highly diminished. So here we'll see one more case. When the object is placed anywhere, it's not necessary that we need to place it at 2 F1, F1. So anywhere you place here, if you place it anywhere between optic center and infinity, same time. 1 second, I have not drawn the lens over in this case. Draw this way. Concave lens. Now coming back to this part, draw parallel, then diverging, it will diverge. One more, you draw passing through optic center undeviated. Now these two will not meet this ray, so we will produce this ray so that it appear to pass through F1. So now when produced back, they meet, these two rays meet at this particular point. Now here you can see image, in this case image position is on the same side as of the object, and nature is virtual and erect. Size, this is very important, size here is diminished. Size is diminished. So when we have drawn the ray diagram for the special case, in this for convex lens, we got an enlarged virtual erect, but for concave lens we will always get a diminished virtual and erect. Do keep this in mind, it will really help you in the numericals. I hope you all understood.